From the Big Bang to alien civilizations, the story of our universe is far stranger and more magnificent than most imagine. In this journey, we'll peel back the layers of cosmic history, from the explosive birth of space and time to the tantalizing possibility of life far beyond Earth. This is Secrets of Our Universe. Chapter 1. The Echoes of Creation. Imagine the sky above you, not the sky you know, but a sky so dark and vast that it holds every star that has ever been, and every star yet to be born. As you float here in your mind's eye, picture yourself drifting far beyond Earth, past the moon, past the outer planets, until even the sun is only a glimmer behind you. Space is silent. Space is gentle. Space is infinite. Now, let's go back. Not just back in distance, but back in time. Back before our solar system. Before the Milky Way. Before any stars at all. All the way to the very first instant of everything. For billions of years, people have wondered about this moment. Ancient stories spoke of cosmic eggs, primordial oceans, great birds or gods speaking worlds into being. In China, there is the story of Pangu splitting the cosmic egg. In Egypt, the story of Nun, a dark, boundless sea from which the first mound rose. In physics today, we use a different name, the Big Bang. But in a way, we are still trying to tell the same story, how something arose from something we cannot yet fully. In modern cosmology, before time began, there was no empty space waiting to be filled. There was no outside. There was only a state of energy and potential beyond our common experience. Some physicists call it a quantum vacuum, others a singularity. But all agree that our usual ideas of nothing simply do not apply. If you are lying down, close your eyes for a moment. Picture a tiny seed, smaller than a grain of sand, yet containing an entire forest within it. Now imagine that seed not as a thing floating in space, but as space itself. In less than a trillionth of a second, that seed swelled. This is what scientists call inflation, a rapid, almost unimaginable expansion that took the newborn universe from subatomic to cosmic size in the blink of an eye. During that fleeting moment, delicate ripples formed like faint breezes across a still pond. Those ripples were tiny variations in density. They were so small we would never have noticed them had they been on Earth. Yet over billions of years, gravity would amplify them into galaxies, clusters, and entire webs of stars. Every swirl of light you've ever seen in the night sky began as one of those ripples. Try to picture it now. A sea of energy, perfectly smooth except for faint waves. Each wave a future home for stars, planets, and maybe life. This is the first chapter of everything. As the infant universe expanded, it also cooled. Temperatures dropped from trillions of degrees to billions, then millions. Out of pure energy, the first particles formed, quarks, electrons, neutrinos, the building blocks of matter itself. At this stage, time was only microseconds old. Yet in those microseconds, the basic ingredients of your body, of the Earth beneath you, and of the distant galaxies were being decided. Protons and neutrons combined. Light and matter danced in a hot fog. Space was a glowing soup, dense, opaque, and roiling with energy. Pause here. Take another slow breath. You are picturing a universe less than 1 second old. All of space everywhere was the size of a tiny sphere. Everything we see today, every star, every planet, every thought you've ever had was compressed into a volume smaller than an orange. And yet, already the laws of nature, gravity, electromagnetism, the strong and weak nuclear forces, were emerging out of symmetry like notes from a chord. These laws would guide the universe forever, from the smallest atom to the largest cluster of galaxies. This is the mystery before the beginning. Not a blank void, but a fertile nothingness whose nature we are only starting to guess. As you drift with me through this first moment, let the scale sink in. We are talking about a time so early that a single heartbeat would have lasted longer than the entire process we are describing. Still, in that instant, the stage was set for everything to come. We've arrived in the first second of cosmic time. The universe has already swollen from subatomic to vast. Temperatures fall from trillions to mere billions of degrees. Particles are colliding, merging, and decaying like a grand cosmic dance. Scientists call the next phase inflation. Imagine blowing up a balloon, but instead of air, you're stretching the fabric of reality itself. Distances double and double again at unimaginable speed. Space doesn't expand into something. It's the something expanding. If you could ride along, you'd feel no wind, no acceleration, only more and more room appearing between every point. The wrinkles formed during inflation are delicate, a billionth of a degree difference here, a billionth there, but they will shape the universe forever. Where the fabric is a tiny bit denser, gravity will gather matter. Where it is a tiny bit emptier, cosmic voids will grow. You can think of it like the soft rise and fall of dough before it bakes into bread. As the universe cools further, the seething plasma of particles begins to thin. About 3 minutes after the Big Bang, a simple but profound chemistry starts. Nucleosynthesis. Protons and neutrons fuse to form the first atomic nuclei, mostly hydrogen, a little helium, traces of lithium. These will be the raw ingredients for the first stars. Yet for hundreds of thousands of years, light cannot travel freely. Photons scatter off electrons like beams in a fog. The cosmos is a glowing, opaque mist. Imagine being inside a cloud lit from within, everywhere bright, but nothing distinct. Then, about 380,000 years after the beginning, a quiet miracle happens. The universe has cooled enough for electrons to settle into orbits around Nufi. Atoms form. The fog clears. Light is released. That first light is still with us today, stretched by cosmic expansion into microwaves. Astronomers call it the cosmic microwave background, the oldest light we can see. It is, in a sense, the universe's baby picture. 2 engineers, Arno Penzias and Robert Wilson, stumbled upon it in 1965 while calibrating a radio. They thought it was pigeon droppings at first, a persistent hiss they couldn't explain. It turned out to be the echo of creation itself, a whisper from 13.8 billion years ago. If you close your eyes, imagine a soft, all-encompassing glow. It has no center, no edge, only gentle variations like the modeling on an ancient wall. Those modelings are the imprints of the earliest fluctuations. When satellites like COBE, WMAP, and Planck mapped it in detail, they gave us a precise blueprint of the young cosmos. After this release of light, the universe enters what cosmologists call the Dark Ages. There are no stars yet, only vast clouds of neutral hydrogen. Gravity works slowly and visibly, gathering matter into clumps. Think of morning mist coalescing into drops on a leaf, or dew forming before sunrise. In the darkness, the seeds of galaxies are gestating. For tens of millions of years, space is quiet. No starlight, no galaxies, only a cold, expanding ocean of gas. But slowly, at the densest points, the gas contracts. Pressure and temperature rise. The first stars flicker into existence, their ultraviolet light piercing the gloom. This period, the reionization of the universe, marks the dawn of cosmic structure as we know it. Pause again. Picture yourself drifting through that dark ocean. Around you are invisible filaments of hydrogen stretching for light years. In the distance, faint points of blue-white light, the very first stars begin to shine. Their radiation carves out bubbles, like lanterns in fog. This is the bridge between creation and the cosmos we see today. From quantum ripples to star-forming clouds, the stage is being set for galaxies, planets, and eventually life. All of it began here in the afterglow and darkness of the infant universe. Breathe in slowly and out again. The universe around you is still young, a few 100 million years old. In human terms, it sounds ancient, but in cosmic terms, it is still an infant, taking its first breaths of starlight. In the quiet dark, the densest knots of hydrogen and helium begin to collapse under their own gravity. Picture great clouds of gas, each 1,000,000 times larger than our solar system, drifting silently until they grow heavy enough to fall inward. As they shrink, they spin, warming and compressing. Deep inside, pressure builds until, like the striking of a match, nuclear fusion ignites. The first stars are born. Astronomers call them population 3 stars. They are unlike anything we see nearby today, enormous, hot, and short-lived, burning blue-white, pouring out ultraviolet light and streams of particles. Their energy ends the cosmic dark ages. Slowly the fog of neutral gas is reionized. The universe becomes transparent again. These first stars do something even more profound. In their hearts they forge new elements. Hydrogen becomes helium, helium becomes carbon and oxygen. When they die in supernova explosions, these elements are scattered like seeds into surrounding space. Without them, there would be no planets, no oceans, no life. Pause here. Imagine drifting near one of those first stars. It is enormous, perhaps hundreds of times the mass of our sun, blazing so fiercely that its light would be blinding even from a great distance. Around it, the dark intergalactic gas glows faintly as radiation strips electrons from atoms. Bubbles of ionized gas spread outward, overlapping and merging until the entire cosmos is suffused with starlight. Clumps of matter drawn together by gravity merge into larger structures. What were once small clouds now become the first galaxies, collections of stars bound together, spinning slowly like newborn pinwheels. Galaxies themselves are not solitary. They form along filaments of invisible dark matter, an immense cosmic web. If you could see it, it would look like a lacework of glowing strands and empty voids stretching for billions of light years. Over hundreds of millions of years, these galaxies grow by pulling in gas and by colliding with one another. A small galaxy may fall into a larger one, its stars becoming part of the bigger system. These cosmic mergers shape the galaxies we know today, including our own Milky Way. Visualize yourself now gliding through that early universe. You drift between newborn galaxies, glowing softly in shades of blue and white. Some are irregular clouds. Some already show the beginnings of spiral arms. Around you, dark matter filaments act like invisible scaffolding, guiding the flow of gas and galaxies alike. This is the era when the architecture of the cosmos is laid out, the great web that will persist for billions of years. The tiny ripples from the Big Bang have grown into vast structures. The universe is no longer just expanding. It is organizing, building the stage for everything that will follow. Breathe in and out. The first stars and galaxies have lit up the universe. Their light travels outward, filling space. But between those islands of brightness lies something even grander, the cosmic web, a vast invisible structure of dark matter and gas. If you could stand far enough away to see it all at once, the web would look like a delicate lace or a spider's silk spun across the whole of space. Bright knots mark the densest clusters where galaxies gather. Thin filaments stretch between them like glowing highways. In between are immense voids, regions, so empty you could travel for tens of millions of light years without meeting a single star. Imagine yourself drifting slowly along one of these filaments. Below you, rivers of galaxies flow, each a whirl of hundreds of billions of suns. The scale is beyond comprehension, yet the pattern is gentle and ordered. In the faint darkness, you sense the quiet pull of gravity guiding everything. Now pause for a moment. Look back toward Earth. Our own Milky Way sits at the edge of a modest filament inside a small cluster called the local group. What seems like an entire universe to us is just one tiny thread in this cosmic tapestry. Astronomers have learned to map this web using surveys of galaxies and by detecting faint absorption lines in the light from distant quasars. Supercomputers simulate it, showing how small ripples in the early universe grow into the lacework we see today. These simulations look uncannily like neural networks in a brain, patterns repeating at different scales. As you drift through this silent architecture, remember, everything you're picturing is in the past. The light from these early galaxies has taken billions of years to reach us. Looking deep into space is literally looking back in time. Telescopes are time machines. Consider the Hubble Ultra-Deep Field, a patch of sky no bigger than a grain of sand held at arm's length. When Hubble stared at it for days, thousands of faint galaxies appeared, each a snapshot from billions of years ago. Some of the faintest were born less than 1 billion years after the Big Bang. Now the James Webb Space Telescope, JWST, is extending our vision even further. With its infrared eyes, it peers through cosmic dust to see the first galaxies more clearly than ever before. Every image is a window into an era when the universe was young, chaotic, and full of promise. Picture yourself at the eyepiece of such a telescope. The field of view fills with countless tiny smudges of light, each one a city of stars, some so distant their light set out before Earth even existed. You're not just seeing them, you're seeing the past. Let your breathing slow as you imagine this. Galaxies like faint fireflies in an endless night. Filaments like silver threads. Time flowing backward with every photon that enters your eyes. The deeper you look, the younger the universe becomes, until you're almost back at its dawn. Let's slow down even more. We've drifted across the filaments of the cosmic web, looked back through billions of years of light, and glimpsed the universe as it once was. Before we continue forward into more discoveries, take a gentle pause. In your mind's eye, zoom out. Everything you've ever known, every tree, every ocean, every memory, every heartbeat is on a small blue planet, circling an average star in a quiet corner of an ordinary galaxy. That star is just one of hundreds of billions in the Milky Way, and the Milky Way is just one thread among billions of galaxies in the cosmic web. The scale can feel overwhelming, but it can also be comforting. If the universe is this vast, then the stories unfolding within it, including ours, are part of a much greater tapestry. The iron in our blood, the calcium in our bones, the oxygen in our lungs were forged inside ancient stars that lived and died long before Earth existed. You are quite literally made of stardust. Let that sink in. Inhale slowly and exhale slowly. The same forces that guided the first atoms into galaxies also shaped the molecules in your body. The same cosmic history you're hearing now is written into every cell of you. We are not separate observers. We are participants in this grand unfolding. The ancient light that reaches our telescopes is also the ancient light that bathed the raw materials of our world. The hydrogen in the water you drink has been unchanged since the Big Bang. Each sip, each breath is a quiet connection to the beginning of time. So as you float in this imagination, let your thoughts drift like cosmic dust. You are part of this story. The universe is not just out there, it's within you, echoing in every heartbeat. When you're ready, we'll continue our journey outward again to see how the first stars seeded the heavier elements, how they lived brief, brilliant lives, and how their explosive deaths shaped everything that came after. But for now, just breathe and rest in the wonder of being here, listening to a story as old as time itself. Chapter 2. The Stellar Nurseries and Galactic Architects. The birth of the first stars. You're still floating in the cosmic web, but something is changing. In the darkness between filaments, clouds of hydrogen and helium, the simplest elements born in the Big Bang are gathering. Gravity, patient and invisible, draws them together like a slow-motion dance. Imagine these clouds as vast oceans of gas spanning light years across. Within them, tiny ripples grow denser, cooler, and heavier. The temperature drops, the gas condenses, and deep inside the densest knots, something wonderful happens. The very first stars ignite. These are not stars like our sun. They are enormous, tens, even hundreds of times more massive, burning fiercely and briefly. Their light is a brilliant blue-white, harsh and pure. In a universe still mostly dark, they shine like cosmic lighthouses. As you drift near one of these stellar nurseries, picture immense pillars of gas sculpted by ultraviolet light, like the famous pillars of creation in our own Milky Way's Eagle Nebula. But these first nurseries are even grander, untouched by heavy elements, made only of primordial gas. Inside, nuclear fusion begins. Hydrogen becomes helium, releasing floods of energy. This process not only powers the star, it forges new elements, the seeds of chemistry beyond hydrogen and helium. With every second, the cores of these massive stars are quietly creating the ingredients for future planets, oceans, and life. Their lives are short, just a few million years. But in cosmic time, those million years are like a single heartbeat. When they die, they do not fade gently. They explode as supernovae, scattering heavier elements like carbon, oxygen, silicon, and iron into surrounding space. Each explosion sends shock waves through the gas, triggering new waves of star formation. Pause for a breath. In and out. What you're picturing now is the universe's first great act of recycling. The raw hydrogen and helium from the Big Bang become stars. The stars create heavier elements. Those elements seed new clouds. And out of those clouds come the next generations of stars, smaller, longer-lived, more complex, and eventually the possibility of planets. Even our own sun is at least a third-generation star. The gold in your jewelry, the calcium in your teeth, the iron in your blood, all were born in long-dead stars like these, then flung outward to be gathered up again. Every star you see in the night sky is part of this unending cycle of birth, life, death, and rebirth. Let this image linger. A universe once dark, now dotted with newborn stars. Their light traveling outward for billions of years, still reaching us tonight as a soft glow in our telescopes. A cosmic nursery, quietly working, shaping everything that will come. The lives and deaths of giants sculpting the galaxies. The first stars are burning. Their light has begun to lace the darkness with faint blue-white threads. For a few million years they shine with extraordinary power, pouring energy into the space around them. These giants are restless. Radiation from their surfaces pushes back the surrounding gas, carving cavities and bubbles. Inside a stellar nursery, the scene is like a slow-motion storm. Pillars of gas being eroded, caverns opening, shock waves rolling outward for light years. Take a moment. Picture yourself drifting at the edge of one of these bubbles. You're weightless. Before you stretches a glowing wall of gas, lit from within by the ultraviolet light of massive newborn stars. Threads of material curl and twist like soft smoke. Deep inside the star's cores, nuclear furnaces are steadily forging heavier elements. Helium becomes carbon and oxygen. Later, even heavier nuclei appear: neon, silicon, iron. These elements will one day be the building blocks of planets, oceans, and life. But the stars' time runs out quickly. Their cores grow too heavy to support themselves. In a moment, in the blink of a cosmic eye, a star collapses, then rebounds in a titanic supernova. The explosion outshines an entire galaxy for a few days or weeks. You can almost hear it, if you imagine hard enough, a silent flash, a rolling wave of energy spreading through the interstellar medium. The surrounding gas is seeded with carbon, oxygen, magnesium, iron, a glittering dust of future worlds. These supernovae do more than enrich the cosmos. Their shock waves compress nearby clouds, triggering fresh rounds of star birth. One generation of stars gives birth to the next. In this way, the deaths of massive stars sculpt the architecture of galaxies, sweeping gas into new patterns, stirring it, mixing it, setting the stage for the complex structures we see today. Even black holes are born here. Some of the most massive stars collapse directly into them, leaving behind invisible anchors that will help shape their galaxies' cores. Later, entire galaxies will merge, and their central black holes will dance and grow. Breathe in slowly, and exhale slowly. Every glittering point in the sky tonight, every metal in our blood, every spark of life on Earth owes its existence to these ancient giants. Their brief, furious lives wrote the chemical alphabet of the cosmos. Imagine a galaxy seen from far away. Spirals of stars glowing softly, dark lanes of dust, hidden nurseries where new stars are forming. Each spiral arm a record of countless births and deaths, supernova and shock waves, an unending cycle. As you let that picture settle in your mind, remember, you are drifting not only through space, but through time. The light from the oldest supernova is still traveling. Some of it may only now be reaching our telescopes, a faint whisper from a star that died billions of years ago. In this quiet, as you breathe and drift, you can sense the continuity, the universe steadily creating, recycling, evolving, shaping itself over and over. And in its patient rhythm, galaxies emerge, grow, and change, becoming the grand structures we see today. The dance of galaxies, mergers, and growth. Let your breathing find a steady, quiet rhythm. You've watched the first stars live and die. Their debris has seeded space with heavier elements. Clouds collapse, new stars are born, and slowly the first galaxies emerge, glowing islands of light in the dark sea of space. But galaxies are not fixed. They move, they drift toward one another, drawn by gravity's invisible threads. Over millions and billions of years they begin to interact. Their shapes distort, tidal tails of stars and gas arc outward like delicate streamers. Imagine two small galaxies gliding together, their dark matter halos overlapping first, then their stars slowly mingling. In your mind's eye, you can see loops and swirls forming, stars being cast into long, faint trails. The process is slow, graceful, almost balletic. These encounters are not rare accidents. They are a fundamental part of cosmic growth. Large galaxies are built from smaller ones. Every massive spiral or elliptical you see today is the result of countless mergers stretching back to the dawn of time. Even our own Milky Way has swallowed many dwarf galaxies and will one day merge with the Andromeda Galaxy. Pause for a moment and picture that future. Two great spirals moving toward each other over billions of years, their disks warping, streams of stars crossing the void, until at last they fuse into a single, enormous galaxy. The night sky of Earth's far future will be filled with Andromeda's light, a slow cosmic embrace. Mergers do more than mix stars. They also drive waves of star formation. Gas clouds collide and compress, igniting bursts of new stars. Central black holes feed on inflowing gas, becoming quasars that blaze across the universe. This is how galaxies grow not just in size, but in complexity and brilliance. Inhale slowly and exhale slowly. Think of the cosmic web you floated through earlier. At its nodes, clusters of galaxies gather like sparkling jewels. Inside each cluster, galaxies orbit one another, collide, and merge in a slow dance. Over eons, these processes shape the grand architecture of the universe. Even now, as you listen, light from distant collisions is streaming toward us. Telescopes catch the faint arcs and streams left by mergers long past. Supercomputers recreate them, showing how simple clouds became the rich galactic ecosystems we see today. This is the universe as an artist, weaving structures on scales beyond imagination. Threads of dark matter, rivers of gas, sparks of stars, all moving in harmony, all sculpting the stage on which worlds and life can arise. A gentle reflection from starlight to possibility. Breathe in and out. We have traveled from the universe's first stars to the sprawling cities of galaxies. We have watched titanic suns live brief, brilliant lives, then scatter their ashes into space. We have floated above merging galaxies, their shapes warping in slow cosmic dances. All of this, every ripple and collision, is part of a single process, the universe taking the simplest ingredients and, step by step, creating complexity. Hydrogen and helium gathered into stars. Stars forged new elements. Explosions scattered them far and wide. Gravity pulled those enriched clouds into larger and larger structures. Galaxies grew, spirals unfurled, clusters gathered, webs formed. Pause and imagine what that means. When you look at a galaxy through a telescope, you're not just seeing light. You're seeing billions of life cycles, billions of stars born, living, and dying. You're seeing the story of change, written over billions of years. And you're seeing the prelude to something else. Because inside these galaxies, within the quiet arms of new stars, the ingredients for worlds are waiting. Heavy elements drift and settle, coalescing into dust and rock and ice. Around young suns, disks of matter whirl and flatten, hinting at the possibility of planets. Inhale slowly, exhale slowly. Every breath you take connects you back to these ancient processes. The oxygen in your lungs, the iron in your blood, the gold on your finger, all were forged in some long-dead star and then woven into the fabric of a galaxy before our solar system was born. As this chapter closes, picture the universe not as a cold expanse, but as a patient gardener, sowing seeds of matter and light, tending them through cycles of birth and death until conditions are ready for worlds, and maybe for life. In the next chapter, we'll drift closer to these seeds. We'll watch planets form, oceans condense, and wonder whether the building blocks of life can leap from one world to another. But for now, rest in this vastness. Stars, galaxies, and the quiet promise of worlds yet to come. Chapter 3, The Cradle of Life, Planets and Panspermia. Whirling disks and the birth of worlds. Let your breathing return to a slow, easy rhythm. We're leaving the grand sweep of galaxies now, drifting inward toward the smaller, quieter spaces where stars are born with families of worlds around them. In the shadowed arms of a spiral galaxy, a new star glows. Around it swirls a wide, flat disk of dust and gas, a protoplanetary disk, shimmering faintly in the starlight. This is the nursery of planets. Tiny grains of dust collide and stick, forming pebbles, then boulders, then mountain-sized bodies. They orbit in gentle ellipses, slowly sweeping up more material, growing heavier with each lap around their sun. In your mind's eye, you float above this disk. You see lanes and gaps carved by newborn planets clearing their paths. Clumps of ice and rock glint like slow-moving sparks. Closer in, the young star's warmth drives lighter gases outward. Farther away, frozen worlds form in the cold. Over millions of years, a planetary system emerges. Rocky planets near the star, gas giants farther out, icy comets at the edge. Each one a world with its own future, its own story waiting to unfold. Think of our own solar system's beginnings. 4.5 billion years ago, our sun also sat at the center of a swirling disk. Within that disk, Earth was just a cluster of dust and rock. Collisions, gravity, and time sculpted it into a planet. The heavy elements came from long-dead stars, scattered across space, gathered into a new home. Breathe in slowly and exhale slowly. Now imagine the thousands of other stars across the galaxy with their own disks. Telescopes like Kepler, TESS, and now the James Webb Space Telescope are revealing thousands of exoplanets, from giant, hot Jupiters to small rocky worlds in the temperate zones of their stars. Some may be like Earth with oceans and clouds. Some may be utterly alien. Each one is a hint that worlds are common, not rare. As you drift above the disk, let the image soften. Dust turning into rocks, rocks into planets, planets circling their suns. The slow cosmic choreography that has been repeating for billions of years, creating places where life might one day arise. Worlds beyond in life's cosmic journey. Stay with your slow breathing, in and out. You're still drifting above a young solar system, but now lift your eyes to the wider galaxy. Every point of light you see is a star with its own story, its own retinue of worlds. For most of human history, we could only imagine these other planets. But in the last 3 decades, astronomers have begun to find them. The first hints came from tiny wobbles in a star's motion. Later, faint dips in starlight betrayed the passage of a planet across its face. One by one, worlds were revealed. Hot Jupiters skimming their stars, super-Earths with deep oceans, gas giants circling in cold darkness. Now, telescopes such as Kepler, TESS, and the James Webb Space Telescope are extending our vision even further. With them, we not only detect planets, we can begin to read their atmospheres, sniffing for water vapor, oxygen, or carbon dioxide, the chemical whispers of habitability. In the quiet of the control rooms, scientists stare at curves of light, hunting for the faint signatures of another Earth. Pause for a moment and picture yourself gliding past one of these distant exoplanets. Clouds drift over alien seas. Strange continents curve beneath a different sun. The air might be unbreathable to us, but somewhere on its surface molecules are interacting. Chemistry is unfolding, and perhaps life, simple or complex, is beginning to stir. Breathe in slowly, exhale slowly. The idea that life could be a cosmic traveler has a name, Panspermia. It is the hypothesis that life's building blocks, or even hardy microbes, can hitch rides on asteroids, comets, or dust grains crossing the gulfs between worlds. Meteorites from Mars have landed on Earth. Comets have been found rich in organic molecules. In the vast timescales of the galaxy, such journeys may be common. We don't yet know if Panspermia has actually seeded life elsewhere, or if it helped start life here. But the idea is a gentle reminder that life's potential may not be confined to one planet. The elements forged in stars, gathered into planets, might also carry the seeds of biology from one cradle to another. Let this image form in your mind, not a lonely Earth, but a galaxy alive with possibilities, dusted with organic molecules, dotted with worlds where chemistry experiments are running in parallel. Each one a tiny blue spark in a vast, dark ocean. As you breathe and drift, you are part of this possibility. The atoms in your body, the molecules of your DNA, once lay in the heart of a star. then in the dust of a disk, then in the waters of a planet. You are a product of cosmic evolution, and perhaps not the only one. A gentle reflection, worlds within worlds. Inhale slowly and exhale slowly. We have floated through clouds of dust, becoming planets. We have glided past alien skies. We have wondered if life's seeds might leap from one cradle to another across the deep gulfs of space. When you picture the galaxy now, don't see it as empty darkness. Picture a field of stars, each surrounded by its own family of worlds. Some small and rocky, some large and gaseous, some frozen, some bathed in warmth. Around each one, the slow dance of chemistry unfolds. The heavy elements forged in ancient stars have settled into planets, moons, and oceans. The organic molecules detected on comets and interstellar clouds are the same ones at the heart of your cells. In a very real way, the universe is experimenting over and over again with the ingredients of life. This chapter has been a drift inward, from galaxies to stars, from stars to planets, from planets to the hint of life. It's a journey that mirrors cosmic history itself, step by step, toward greater complexity. Pause for a moment and let that thought settle. Every world, every ocean, every living cell is an echo of processes begun in the first seconds after, from inflation to dark matter webs, from the first stars to supernovae, from dust to disks, from disks to planets, and perhaps from planets to life. Breathe in slowly, exhale slowly. As you lie here listening, you are part of this story. Your atoms, your breath, your heartbeat are links in an unbroken chain of cosmic evolution. In the next chapter, we will look outward again, not backward in time, but forward to the accelerating universe, the mystery of dark energy, and the possible fates awaiting everything you've just imagined. But for now, rest in the image of a galaxy alive with worlds, each one a cradle of potential. Chapter 4, Cosmic Crossroads, Future and Fate. The expanding universe. Take a deep breath in and let it out slowly. Now imagine the universe not as a static backdrop, but as something alive, stretching, growing. Ever since its first moments, space itself has been expanding. Galaxies are not flying through empty space like ships on an ocean. Rather, the ocean itself is swelling, and the galaxies drift apart, because the fabric beneath them stretches. This expansion was first glimpsed by Edwin Hubble in the 1920s. Looking at distant galaxies, he saw their light was shifted toward the red, a cosmic fingerprint of their motion away from us. The further a galaxy lay, the faster it receded. That simple relationship told us something profound. The universe itself is expanding. For a while, astronomers thought gravity might slow this expansion down. After all, everything pulls on everything else. Maybe one day the expansion would stop and reverse, like a ball tossed into the air, falling back to Earth. But in the late 1990s, teams using the Hubble Space Telescope discovered something shocking. The light from distant exploding stars, supernovae, showed that the universe wasn't slowing down. It was speeding up. This cosmic acceleration is one of the deepest mysteries in science. We call the cause dark energy. Not because it is literally dark, but because it is unknown. It appears to make up about 70% of the total energy of the universe, yet we cannot see or touch it. We only infer its presence by the way it pushes galaxies apart faster and faster. As you breathe slowly, picture space as an endless, stretching fabric. Imagine tiny dots on a balloon. As the balloon inflates, the dots move away from one another. The faster the balloon grows, the faster the dots separate. This is what is happening all around us, on scales too vast for our senses to grasp. In this cosmic future, galaxies will drift further apart. The night sky, billions of years from now, will be far emptier than it is today. New stars will form less frequently as raw material thins out. Our cosmic neighborhood, once bright with possibility, will grow quieter and dimmer. But tonight, as you listen, you are still in a universe alive with light and activity. Galaxies colliding, stars being born, planets spinning. The great expansion is gentle enough to give us time to look, to wonder, to understand. In the next part of this chapter, we will travel even farther forward, to the ultimate fates scientists have proposed: heat, death, the big rip, the big crunch. Each is a different ending to the same cosmic story. But for now, breathe in slowly and out slowly, and let the image of an expanding universe carry you. The possible fates. You're still floating in that ever-stretching fabric. The galaxies are like faint lanterns, drifting farther and farther away. As you breathe slowly in and out, you can imagine time speeding forward, billions of years into the future. What will happen to everything you've just pictured? Scientists don't have a single answer, but several scenarios, each one a different kind of ending. Heat death. The first is sometimes called the heat death of the universe. In this future, expansion continues forever. Stars burn through their fuel, one by one, until they go dark. Galaxies grow dim, then invisible. Black holes slowly evaporate. Energy is spread so thinly that no new structures can form. It's not an explosion or a collapse. It's a long, cold fading. A universe in perfect balance, but without change, without new light. The big crunch. Another possibility reverses the story. If dark energy behaves differently in the future, gravity could someday win. The expansion might slow, stop, and then reverse. Galaxies would begin to move back toward one another. The night sky would grow brighter as everything collapses inward. Eventually, all matter and energy would converge into a single dense point, a mirror image of the Big Bang, sometimes called the Big Crunch, the Big Rip. And then there is the strangest of all, the Big Rip. In this scenario, dark energy doesn't remain steady. It grows stronger with time. The expansion accelerates so violently that not only galaxies, but stars, planets, and even atoms are pulled apart. Space itself tears. It is an extreme but mathematically possible fate, a universe unstitched at the seams. These are not prophecies, but ideas, ways of thinking about the unknown. Each scenario arises from the same basic observations of cosmic expansion, but each depends on how dark energy behaves, something we still cannot explain. As you lie there, breathing gently, you might picture these endings not as frightening, but as part of a natural story. Just as stars have life cycles, perhaps the cosmos does too. Creation, change, and dissolution are woven into the fabric of everything. In our next, quieter section, we'll shift the focus from the universe itself to humanity's place in it. How far in the future we might adapt, travel, or even outlive some of these cosmic changes. But for now, breathe in slowly and out slowly, and let the three futures, the cold fading, the collapsing crunch, the tearing rip, drift like distant dreams. Humanity's long-term cosmic destiny. Breathe in slowly and let it out. We've drifted across billions of years in our minds, watching stars burn out and space stretch. But within that vastness is a small blue planet, and on it a species looking up at the night sky. That's us. Right now we are at the very beginning of our cosmic journey. Our rockets reach only the nearest planets. Our signals travel at light speed, but only for a few decades. And yet, in our minds, we already explore the entire universe. Scientists and dreamers imagine futures in which humanity becomes a multi-planet species. Terraforming Mars, building habitats in orbit, mining asteroids. These ideas are not just science fiction, but sketches of possible steps toward survival beyond Earth. Farther ahead still are the concepts of interstellar travel. Even at a small fraction of light speed, a probe could reach nearby stars in decades. Projects like Breakthrough Starshot are early glimmers of this ambition. In a universe that may slowly grow colder and emptier, reaching out to other worlds may be our way of keeping the flame of life. Some thinkers imagine generation ships, self-contained ecosystems traveling for centuries. Others imagine hibernation, warp drives, or using the energy of stars to power civilization. We cannot know which, if any, will be realized. But the impulse to explore, to survive, to create, that impulse is as much a part of the universe as any star or planet. Even in the face of cosmic endings, we are not just spectators. The same atoms forged in ancient stars are now in your body, in your breath. You are the universe becoming aware of itself. Breathe in slowly and out slowly. Picture future humans, perhaps with new forms and new minds, watching new skies from worlds we cannot yet imagine. Picture life adapting to cosmic changes, spreading, transforming. Our story is still being written. This chapter has taken us from an ever-expanding universe through possible cosmic fates, and now to our own tiny, bright thread in that tapestry. In the next chapter, we'll look outward once more, to the search for others, to the question of whether we are alone. For now, let the image of countless possible futures float quietly in your mind. The stars are still shining. The story is still unfolding. Chapter 5, The Search for Others. Are we alone? The great question. Take another deep, easy breath in and let it out slowly. All through our journey so far, we've seen the universe grow from a spark into stars, planets, and perhaps the ingredients for life. But one question rises quietly above all the others. In all this vastness, are we alone? The Milky Way contains hundreds of billions of stars. Around most of those stars we now know are planets. Many of them are roughly Earth-sized. Some sit in that gentle zone where liquid water might flow. On purely statistical grounds, life elsewhere seems likely. And yet, when we look and listen, the stars are silent. This puzzle is known as the Fermi Paradox, named after physicist Enrico Fermi, who once asked, simply, where is everybody? If life can emerge, evolve intelligence, and build technology, why haven't we seen signs of it yet? For decades, scientists have used radio telescopes to scan the skies for signals. organized patterns of radio waves that might betray an alien civilization. These efforts go under names like SETI, the Search for Extraterrestrial Intelligence, and more recently, Breakthrough Listen, a project using some of the world's largest radio dishes to monitor millions of stars for whispers of technology. So far, the search has returned only natural signals, pulsars, quasars, the steady hiss of the cosmos itself. But the search is still young. Our own radio emissions have traveled only about 100 light years, a tiny bubble in a galaxy 100,000 light years across. As you breathe in slowly, picture that little bubble of radio noise expanding from Earth, a faint, fragile shell of information moving outward at the speed of light. Beyond it lies a silence we cannot yet interpret. Is it empty, or is it simply too far away, too alien, too quiet for us to detect? In the next section, we'll drift deeper into how scientists are widening the search, looking not just for radio signals, but for technosignatures, for subtle clues in starlight, for the fingerprints of life and intelligence on distant worlds. But for now, let the question hang gently in your mind. In this universe of countless stars, are we truly alone? Listening for whispers, the modern search. Take a long, slow breath in and let it drift out. The question of life beyond Earth is not just philosophy anymore. It is an experiment. Around the world, quiet instruments are pointed toward the sky, waiting. One of the most ambitious efforts is called Breakthrough Listen. Using some of the largest radio telescopes on Earth in California's hills, in Australia's outback, in the mountains of South Africa, astronomers are scanning millions of stars for any sign of artificial signals. They sift through enormous streams of data, filtering out human-made noise, satellites, aircraft, cell towers, leaving only the faintest cosmic murmurs. But radio waves are just one path. Scientists are now thinking in terms of technosignatures, any observable sign of technology on a planetary scale. For example, an unusually bright spot in a planet's night side might be city lights. A strange chemical mixture in an atmosphere might be industrial pollution. An odd pattern of starlight could hint at huge orbiting structures, vast solar collectors or habitats. Telescopes like JWST and upcoming observatories are beginning to take the first tentative steps toward this. They analyze the atmospheres of distant planets, searching for gases like oxygen, methane, or other complex molecules that on Earth are linked to life. We are, for the first time, capable of sniffing the air of worlds light years away. As you breathe slowly, picture the scene, a radio dish in a desert at night, pointing upward like a cupped hand. Across the ocean, a telescope in the mountains scans a different patch of sky. Above both, countless stars burn quietly. And the data flowing down to Earth may be nothing but cosmic static, or the first faint hint that someone else is out there. The search is not just about answering a question. It is also about perspective. It reminds us that our world is one among billions. It humbles us, but it also connects us. In the silence of the cosmos, we are listening for company. In the next, quieter section of this chapter, we'll imagine what might happen if the silence breaks, if one day a signal comes through. What would that moment mean for us? But for now, breathe gently and let the image of those great dishes under the stars settle in your mind. When the silence breaks, imagining first contact, inhale slowly and let it out gently. Somewhere, deep in the data streaming from a telescope, a small pattern appears. At first it seems like noise, but it repeats, then repeats again. It carries structure, mathematics, rhythm. Imagine a moment when scientists, after decades of searching, confirm that we are receiving a true signal, not a pulsar, not a satellite, but a deliberate transmission from another civilization. No words at first, only patterns. A greeting from minds we have never met. What would happen? Around the world, people would pause. Governments, scientists, and citizens would all look upward. The news would ripple across time zones. There would be wonder, disbelief, fear, excitement. We would, for the first time, know that we are not alone. Some imagine open dialogue, a careful, slow exchange of mathematics, physics, pictures. Others imagine something subtler, simply the knowledge that life and intelligence have arisen elsewhere. That knowledge alone would change our sense of ourselves, of our place, of what is possible. Even if the distance is so great that no reply can be sent for centuries, the very fact of contact would be transformative. It would shrink the universe emotionally, even as its physical scale remains beyond comprehension. As you breathe gently, picture the night sky from your window. All those stars are still silent, but maybe somewhere signals are already on their way, moving at light speed across unimaginable gulfs. Perhaps our own signals are already reaching someone else's night sky, flickering across their telescopes, sparking their own question, are we alone? This is the quiet power of the search. Even in silence, it connects us to a greater whole. It reminds us that we are part of a living cosmos, still unfolding, still full of mystery. Breathe in slowly and out slowly. We have traveled together from the first flashes of the Big Bang to the formation of stars, galaxies, and planets, to the possibility of life, and now to the question of others like us. As you drift toward sleep, hold on to that sense of wonder, the knowledge that your atoms were born in stars, and that your thoughts reach out across light. The story of the universe is not finished. It continues in you, in us, and perhaps in countless beings yet unseen. Good night, under a sky full of possibilities. Take one last slow breath in, and let it drift out. We have traveled together from the first flicker of the Big Bang to the glow of newborn stars, from drifting galaxies to the birth of planets, from the spark of life to the search for minds beyond our own. Each chapter was a step outward and inward at the same time, outward into a universe of unimaginable size and age, inward into a deeper understanding of our own origins. As you lie here now, you are still part of that unfolding story. Your heartbeat, your breath, your thoughts are made of the same elements that forged stars. You are the cosmos becoming aware of itself. The universe is still expanding, still creating, still holding secrets. Somewhere, new stars are igniting. Somewhere, perhaps, life is stirring. And somewhere, a signal may already be traveling through space toward us. Breathe gently. Feel the vastness around you and the quiet within you. Though this recording ends, this story does not. Every sunrise, every night sky, every question you carry forward is part of the same journey, the universe telling itself new stories through you. Sleep now under the same stars that gave you form. Rest in the knowledge that you are woven into something vast, ancient, and beautiful. Good night, and may your dreams drift among the galaxies.